Okay, dear student, in this class we will study about the problems of chapter number 13, reflection of light. Here we will start about data. Data of numerical number 13.1, that is object distance, which is denoted by P is equal to 30 centimeter. Focal length denoted by F, which is 5 centimeter. HO, height of the object, also 5 centimeter. Q, you have to find the position of the image formed in front of concave mirror. So Q is to be find out, as well as the size of the image, mean HI, height of the image, is to be find out. Now solution, we will select this first formula, 1 upon F is equal to 1 upon P plus 1 upon Q. By putting the values from the data, we will get 1 upon F is equal to 1 upon 30 plus 1 upon Q. Now 1 upon Q is equal to 1 upon 5 minus 1 upon 30. So by taking LCM 5 and 30, we get the LCM 30. Now 5 divided by 30 divided by 5, that is 6. 6 ones are 6. Here 30 divided by 30, that is 1. Here we will write 1. So it comes 1 upon 6. By taking inverse, then Q will become 6 centimeter. So the image position is 6 centimeter. Now the second formula, we will calculate the height or size of the image. HI upon HO is equal to Q upon P. By putting the values, HI upon HO is equal to 6 upon 30. And HO is 5 centimeter. Here in the data, size of the object is 5 centimeter. So instead of HO, we will write 5. Now by calculation, it will become 1 multiply 5 upon 5. 5 and 5 cancels. So HI, size of the image, is 1 centimeter. Next, numerical number 2, 13.2. Data is P is equal to 10 centimeter, mean object distance. Q is minus 5 centimeter because the image is virtual. Now we have to find out the focal length. And second one, nature of the mirror, that which type of mirror is being used in this process. Now first of all, we will calculate the focal length, because object distance P and image distance Q is given. 1 upon F is equal to 1 upon 10 and 1 upon Q minus 5. Instead of Q, we will write minus 5. So it comes minus 5 and 10. We get LCM, that is 10. Now 10 divided by 10 comes 1. So we will write here 1. And 5 divided by 10, 2. We will get 2 ones are 2. So minus 1 upon 10. By inversing, we will get F is equal to minus 10 centimeter. Its focal length is minus 10 centimeter. It is convex mirror because the focal length of convex mirror is negative. Therefore, our answer is minus 10. Therefore, we will say the nature of the mirror is convex mirror. Okay, dear student, now problem or numerical 13.3. Its data is P is equal to 20 centimeter object distance. You have to find out the position of the image, which is Q, you have to find out, and focal length F is equal to 15 centimeter. And second thing, we have to find the nature of the image. Now, first of all, we will find the image distance. 1 upon F is equal to 1 upon P plus 1 upon Q. Here 1 upon 15 is equal to 1 upon 20 plus 1 upon Q. Now we will change the position of 1 upon 20. That will become minus 1 upon 20 plus 1 upon 15. Here 1 upon q is equal to minus 3, because 60 we will take the LCM of 15 and 20, which is 60. Now 60 is divided by 20, it comes 3, so minus 3 plus 4. So by subtracting we get 1 upon 60. Inversing the values, q is equal to 60 centimeter, position of the image is 60 centimeter. Because value of q is positive, image distance is positive, therefore it is real image. So it is the nature of the image. Next, numerical number 4, 13.4, its data is P is equal to 24 centimeter, F is equal to 6 centimeter, Q is equal to, you have to find out, height of the image also find out. Height of the object is 12 centimeter. First of all, we will find the image distance, that is 1 upon F is equal to 1 upon P plus 1 upon Q. Here 1 upon F 1 upon 6 and P 1 upon 24. 1 upon Q is equal to 1 upon 6 minus 1 upon 24, because we have to change the position of 1 upon 24, so its sign is changed. Now taking the LCM of 6 and 24, it comes 24. Now 24 divided by 6, it comes 4, and 24 divided by 4, it comes 1, 1 1 is 1. So it comes 3 upon 24. Now by reducing it, it comes 1 upon 8, and by inversing its position, then Q image distance, that is 8 centimeter. Now we will find the height of the image, HI upon HO is equal to Q upon P. Here HI is equal to 8 upon 24 multiply 12. These all the values are given. Now HI is equal to 4 centimeter. So Q is 8 centimeter. Next, numerical number 5, that is F focal length is given, which is 10 centimeter, and magnification of the image, that is given and denoted by M capital, that is 2. And you have to find out the position of the object where it should be placed to get twice magnified image. Now formula for magnification, that is M is equal to Q upon P. Instead of M you will write 2, and now cross multiplication, Q is equal to 2P. Here we will put the formula 1 upon F is equal to 1 upon P plus 1 upon Q. Value of Q is 2P. Instead of Q we will write 1 upon 2P. Here we will take the LCM P and 2P, it comes 2P. Now 2P is divided by P, so remaining is 2. Here 2 ones are 2. Now 2P divided by 2, it comes 1. So here you will write 1, by adding it 3 upon 2P. Here 1 upon 10 is equal to 3 upon 2P. By cross multiplication we get 2P is equal to 30 and P is equal to 30 centimeter. Here dividing the P by 2, it comes 15 centimeter. It comes 15 centimeter. Here divided by 2, it is 15 centimeter. So your answer is 15 centimeter.